Alright, so this last unit is going to focus on something that's a little bit different from what you've been seeing so far in this course. We're going to look at the whole idea of sequences of numbers. So a sequence is just an ordered list of numbers. So picture if you had, number 3 followed by the number 12, followed by the number 15. There might be a pattern to these, there might not be. There's just some sort of list of numbers separated by commas, and it's commas in order. And in theory, if there's a pattern here, it would go on forever. But you just have a list of numbers. And what we're going to be dealing with specifically are sequences of numbers that have specific patterns with them, and we'll talk about that coming up. But in this sequence of numbers, you have different terms. So a term will refer to a number in a particular sequence. So for example, in this sequence I just made up here, this right here, 3 would be the first term, 12 would be the second term, 15 would be the third term, and so on and so forth. And we usually use the notation we use for those terms at the nth term would be called Tn. So for example, this 3, our first term would be called T1 for term 1. This would be term 2, term 3, and so on and so forth. Okay, so the 20th term would be called T20, and the 80th term would be called T80, and so on and so forth. You get the idea, right? But the term just refers to a particular number in a sequence. And last but not least, we have this idea of a general term. And a general term is if there's a pattern to this sequence, then it will be an algebraic formula that will determine the nth term. Okay, so again, we haven't necessarily created one, but if there's a formula, if there's a sequence that has a certain pattern to it, we can, in theory, create a formula to help you generate whatever term we wanted. I mean, you can imagine here, if I want to find out the 78th term of this sequence, even if I knew the pattern, I wouldn't want to continue counting out until get to the 78th term. I want some sort of formula to generate it, so I wouldn't have to spend hours doing so. So again, that's what we're going to look at doing today. But again, you'd have to have a specific pattern into that sequence. So we're going to call that nth term Tn, and we're going to have a formula to generate it, and we'll talk about how to do that coming up. So let's say we have a sequence here, 3, 7, 11, 15, so on and so forth. We want to find the 197th term. This would be one of those times we would want to find what we'd call the general term, the formula to find the term that we want. So here, this sequence actually does have a pattern to it. You can recognize here that we're going up by 4 every single time. Okay, so 3 plus 4 is 7, 7 plus 4 is 11, and so on and so forth. So I can continue on generating the next term in the sequence as long as I continue adding 4. Okay, the only problem is if I want to find the 197th term, that could take me a really long time if I continue to keep counting out. So I want to try and find a general formula, general rule for this. So what I'm going to do for this, I'm just going to take a look at what this sequence looks like on a graph. So looking at a table of values here, if n here is the number of the term, and Tn is the actual term itself. So the first term of this sequence is 3, the second term of this sequence is 7, third term is 11, and so on and so forth. So you follow that pattern out a little bit more, you'll see that the fifth term, 15 plus 4 is 19, and the sixth term is 23. So let's see what that looks like on a graph. So taking a look at Desmos here, I have these terms plotted out, and hopefully you can see a little bit of a pattern here. If you're going up by 4 every single time, this pattern is linear. I could continue this on forever, and again, same pattern, I would have a line here. So if I can find the equation of this line, in theory I could find an equation that could help me find any other term I wanted. Okay, so that's what we're trying to look at here, is trying to find a general way of finding out how we could generate a new term based on the previous terms, and it's going to create a formula. Okay, so let's just leave this current question here on hold for a second here. You might have an idea of how to find this 197th term right now just by trying to find the equation, but let's take a look at the idea of these types of sequences in general. So you notice the sequence we just had, we were going up by 4 every single time. So there was a common amount that we added or subtracted to get to the next term. These types of sequences are called arithmetic sequences. They're called arithmetic because they're just adding a constant value to the previous term. We're going to call that difference, we're going to call that constant value the common difference. We're going to call that D. So for example, if you were to take the second term and subtract the first term, and the third term and subtract the second term, and so on and so forth, because they're going up by the same amount every single time, that would be what we call our common difference. So taking a look at these other examples right here, if we're going 1, 2, 3, 4, well, what are we going up by every single time? We're counting up by 1, so we're going to have a common difference there of 1. If we're looking at 17, 12, 7, 2, well, the pattern here is we're going down by 5 every single time, so we have a common difference of -5. Okay, so if we want to take this and look at a more general case here, If we call the first term a, so in this case, in the first example here, our a is 1, and our second sequence here, our a is 17, just the first term, and we'll call that common difference d. Let's try and come up with a formula for that general term. So, for example, my first term is just a. Well, to find my second term from there, I just add that common difference, so I have a plus d. And again, just because I'm going up by d every single time, to get to my next term here, I'm going to add d again. So there I'm going to have a plus d, which simplifies into a plus 2d. And you can sort of see the pattern from here. I'm going to have a plus 3d for the fourth term, a plus 4d for the fifth term, and so on and so forth. In general, what you'll notice here is that my nth, for whatever term number I want, it's going to be a plus n minus 1 times d. So, for example, for when my n was 7, I added 6 differences. When my n was 6, I added 5 differences. So in general, I'm adding 1 less difference than the term number to the original a value. So we can say our formula for our general term is a plus n minus 1 copies of our difference. So a plus d times n minus 1. And what this lets us do is now we can create, it's a general term. It's a formula that we can use to generate whatever term we want. So now, taking this and going back to our example on the previous page where we're trying to find the 197th term, we have this formula now, and again, it comes from the fact that this was linear. We're going up by a common amount every single time. In this particular example, our first term was 3, and our common difference is 4. We're going up by 4 every single time. So to create a general formula here, my Tn would be equal to a, which is 3, and d is 4, so I get 3 plus 4 times n minus 1. Okay, now if I want to find the 197th term, well, if it's 197th term, that just means that n is equal to 197. Because again, what this formula does helps me generate whatever term number I want because I have a general formula. So if n is 197, the 197th term will be 3 plus 4 times 197 minus 1, which I'll continue on over here. So it's 3 plus 4 times 196, which I can run through my calculator and say it's 787. So without having to count out forever until I got to 197 different terms, I could calculate the 197th term using this general term. Okay, and again, I could calculate whatever term I wanted with this. And this particular general term, again, only works for what we call arithmetic sequences. We're going up by a constant amount every single time. Okay, so now let's look at a couple more examples and try and find the general term. So here I have a sequence 7, 2, negative 3, negative 8. So what we're going to look for here is first to see if the sequence is arithmetic. If it was, there'd be a common difference going from term to term. So going from 7 to 2, you're subtracting 5. 2 to negative 3, subtracting 5, and again negative 3 to negative 8, also subtracting 5. So you have a common difference here. So here we have a common difference of negative 5. Our first term, which we're going to call a, the first term in the sequence is 7. So we can create a general term. So taking my formula from before, okay, I'm going to sub in what I have for a and for d. So again, my first term is 7. My common difference, pardon me, again, my first term is 7. My common difference is negative 5. Okay, I'm just going to simplify that in the next line here. So I have 7 minus 5 times n minus 1. Okay, so again, this is a general term. It's a formula that if I were to choose whatever term number I want, I could sub that into the equation for n and solve whatever that term number is. The only thing I'm going to do here, just to make it a little bit more proper, I'm going to expand and simplify here. So I get 7 minus 5n plus 5, which when I simplify gives me negative 5n plus 12. Okay, so I'd like you to simplify here, just that makes this formula a little bit easier to work with because there's no brackets in it anymore. It's been expanded and simplified. But now in theory I could use this equation to generate whatever term I wanted. The 50th term, the 2000th term, whatever I want. So this is a general term for this particular sequence to generate whatever term you like. Okay, so again, we're going to continue working through these types of with these types of sequences here. So Here I'm asking you to find t20. Now, just to get used to the notation here, when I say find t20, that means find the 20th term. Okay, and let's take a look at the type of sequence we have here. We have 1 over 2, 7 over 6, 11 over 6, 5 over 2. First of all, let's make sure, the other type of sequence we know how to work with is arithmetic sequences. So let's make sure this is arithmetic before we try and find a 20th term. So if you do 7 over 6 minus 1 over 2, try to see how much this goes up by. Okay, this tells you you're adding 2/3 to go from 1 over 2 to 7 over 6. See if that's the same for every single other one. If you do 11 over 6 minus 7 over 6, you get 4 over 6, which is 2/3. And the same thing here, if you do 5/2 minus 11 over 6, you get, again, 2/3. So this sequence is indeed arithmetic. Okay, so now that it's arithmetic, we have our common difference. Okay, and we have our first term, which is a half. We could find a general term. Now, I didn't actually add the general term here, so if you actually wanted to find the 20th term, you could, in theory, continue adding 2/3 out here until you get out to the 20th term. To me, that takes a very long time, so I'm not necessarily going to do that. I find it easier to find the general term first and then sub in 20 into that. The other reason to do that is, let's say I didn't ask you for the 20th term, I asked you for the 75th term or the 298th term, for example. You could be doing that for a very long time. So I'm going to find the general term first. So Tn, again, is a plus d times n minus 1. So my a is a half. My d is 2/3. Okay, now I'm going to simplify that. So I get a half plus 2 over 3n minus 2 over 3, which when I collect my like terms will simplify into 2 over 3n minus, I do a half minus 2/3, which gives me minus 1 over 6. Okay, so that gives me my general term. And remember here I want to find the 20th term, so that means that n is equal to 20. Okay, so if I do that here, on the left side of the equation, say I have Tn is now T20, which is exactly what I'm looking for. So it's going to be 2 over 3 times 20 minus 1 over 6. Okay, I'm going to run that through my calculator. So that gives me 79 over 6 as my 20th term. Okay, just check my answer here. There we go. So again, probably the fastest way to go about this is to find the general term. It's always a good thing to have that because you can generate whatever term you like. And in this particular case, we wanted the 20th term. We subbed that in, and we found our answer. Okay, so hopefully this is making sense so far. And again, we're only dealing with arithmetic sequences right now. We're going to look at some other types of sequences as we move through the unit. But right now, just arithmetic. So here's something I'd like you to think about just at least setting up on your own. So you're given the sequence 3, 15, 27. You want to find out which term has a value of 1,407. At the very least to start, when in doubt, because again, this one looks a little bit different from the ones you've been seeing so far. You have a sequence here. Check to see if it is arithmetic, and if it is, try and create the general term. I'll have you do that to start, and then if you can think about how to find the rest of the part, finding out which term has a value of 1,407, that'd be great. But if you're stuck there, at least get the general term, and then we'll talk about the rest from there. Okay, so you can take a second here and check a general term. It is arithmetic. I'm going up by 12 every single time from term to term. So my d is 12. My first term, my a is 3. So I sub those into the general term equation, and I wound up getting Tn equals 12n minus 9. Now, in this particular case, I want to know which term has a value of 1,407. So I'm not saying find the 1,407th term. I want to know what term number, i.e. which n value, will make the term equal to 1,407. So basically I'm saying, okay, there's some term number that's equal to 1,407. Okay, what n value will make that true? So think about how you set up that equation, and we'll finish this up in part two of the lesson.